All right, geometry. I'm on day 9 notes. The basic premise of these notes are just a couple of different ways for you to help find out internal angles, right? So for starters, or internal arcs. So for starters, we have to know that the entirety of a circle, the degree around the entire circle is 360 degrees. That's for starters. You also have to know that a tangent intersects at one point. Okay. So if I have two tangents that intersect at one individual point, I have a minor arc and then I have a major arc. Okay. So this would be the minor arc, the side toward the angle, and the major arc would be this side further away from the angle. Okay. Now, there's a formula for these. So when I have two tangents, this x right here, the angle measure is going to be equal to, so x is equal to 1/2 times the major minus the minor. Okay, 1/2 times the major minus the minor, and the example that it gives is it says this one is 260 degrees and this one is 100 degrees. So I will know that x, this angle right here, is 1/2 of 260 minus 100. And what does that give me? That gives me what, 160? So half of that must be 80 degrees. Okay? This works on the same principle that we've been using this entire time. You remember moving the circle around the two secants and all that stuff? So, speaking of secants, these are tangents. Tangents intersect one time. Intersect one time. I keep on looking at the camera and get lose track of what I'm writing because it's a little delayed. So, tangent intersect one time. If we have two secants, they intersect two times. That is a secant, and it intersects two times. All right. This one is going to be the same scenario. We have a minor arc here, which is closest to the angle, and we have a major. So that's the minor, and this is the major arc. It's furthest away from the angle. Major. Excuse me. So the larger arc of the two, right? I'm not calling the minor arc major arc in the whole scheme of things. I'm just talking about between the two of these arcs, the major one. This is going to be, we can even substitute the word larger and smaller. Okay. We have the larger arc and the smaller arc. It's going to be the same principle. X is going to be equal to 1/2 of the larger arc minus the smaller arc. And in the example, it says the larger arc is 80 degrees and the smaller arc is 20 degrees. So it'll be 80 minus 20. 80 minus 20 is 60. Half of that is going to be 30 degrees. So we know that this angle will be 30 degrees. Okay? And then having a tangent and a secant, right? So a tangent and a secant. We have a circle. We have one tangent and one secant. Tangent and secant. We actually have covered this before. We just didn't call it a tangent and a secant, but we're using the same principles. So we have our larger arc, which is furthest away from the angle, and our smaller arc, which is closer to the angle. I'm going to say larger and smaller. In the example, it gives this one is 100 degrees and this one is 30 degrees. So we will still do the same thing. X is equal to 1/2 of the larger minus the smaller. Okay, so larger minus smaller is 70. Half of that is 35. So x will equal 35 degrees. Okay, it's a pretty basic premise. It doesn't matter if it's two tangents, two secants. Remember, a secant intersects twice. Tangent intersects only once with the circle. So it doesn't matter if it's two tangents, two secants, or one tangent and one secant, the premise stays the same. If you're missing this angle, you take half of the larger minus the smaller every single time. Now, what if we're missing this piece, but we know this piece? Well, we just input that in for there, and then we would solve for the smaller piece, right? So if we're missing, okay, if we were missing part of the information, right now I'm going to do a secant and a tangent. It's always the same thing. If we were missing a piece of the information, let's say I had x here and I knew that this was going to be 20, and I knew, and I knew that this was a 30-degree angle. I would plug it into that whole formula where it's this angle, that angle is equal to 1/2 of the larger arc minus the smaller arc. You always know which one is larger and smaller because the smaller one's closest to the angle. And then I would solve by multiplying both sides by 2 to get rid of the fraction. And I would end up with 60 is equal to x minus 20. Add 20 to both sides, and I know that x is equal to 80 degrees. It's going to go like that every single time. Okay? So in your examples, you have those. Let's do one more where we're trying to solve the smaller one since we have time. It doesn't matter if I have two tangents or a secant, two secants or a secant and a tangent. So this time I'm going to do two secants. Let's say I'm missing this one. It's the smaller arc, and I have the larger arc. Let's call this 100. And then I know that my angle is, 25 degrees. Okay? I know that that's 25 degrees. So I will use the formula 25 is equal to, because that angle is equal to 1/2 times the larger minus the smaller. I know this one's larger because it's furthest away from the angle. I know this one's smaller because it's closest to the angle. Now we're going to solve. We're going to multiply both sides by 2 to get rid of this fraction. And I will get 50 equals 100 minus x. Okay? Subtract 100 on both sides, and I will get negative 50 is equal to negative x, or multiply both sides by -1, and I will get 50 is equal to x, or that will be 50-degree arc. Okay? In your lesson, you should be able to take that from there to find the actual arc lengths and from past lessons and all that. So I hope that makes sense to you. You can also drop in algebra in there, like number 7. Drop in an algebra to see and combining like terms and then solving using your length as like 2x minus 11 and so forth. Don't forget that if you have two tangents, that the minor arc plus the major arc must always equal 360 degrees. Okay. I hope that adequately explains today's lesson. It's just a little bit of a lesson talking about how to find inside and outside arcs in a circle based on these 3 different types. If you have any questions, please write them in the comments section. Y'all have a wonderful day.